I'll start with the concept of remainder theorem. So what does remainder theorem actually mean? So say so this is a remainder theorem. So remainder of 17 divided by 5 is 2, which we all know. But what I don't know, the same remainder can also be represented as minus 3. So how do we get that? 5 into 4 is 20. 20 minus 3 is 17, and hence this is minus 3 firstly. Secondly, if you see, when you add the magnitude of both the remainder, it's equivalent to 5. So as in, if you add mod of 2 plus mod of minus 3 is equal to 5. So this whole concept is called remainder theorem. So what we will do, I'll take you through some basic mathematical function and how remainder theorem is used to get the remainder of the particular equation. Okay, so to start with addition subtraction. Say the number is 65 plus 78 whole divided by 9. Okay, so 9 into 7 is 63, so I left with the remainder 2 plus 9 into 8 is 72, which is effectively 6, or 9 into 9 is 81, which is effectively minus 3. So we write minus 3. So effectively your remainder is minus 1. So you could have also written 6. Just the way I am doing it is because I want you to understand the concept of how to use a negative remainder. Like I told you, the magnitude of both the remainder, as if whatever the component would have been, and minus 1 is 9. So the remainder could have been, instead of minus 3, be 6 also. As in 9 to 87. So we 2 plus 6 is equal to 8. So what we can see is 9 minus 1 is equal to 8, or 8 plus 1 is 9. So effectively, if there is a negative remainder subtracted from 9 in this case, which is 9 minus 1, you will get the remainder, and that's what the remainder theorem allows you to do. Firstly. Secondly, if you have added the remainders, so that's the part of the remainder theorem. You can add the remainder in case of an addition or a subtraction, basis whatever the mathematical function you are using. Now we will move on to multiplication and division and the uses of remainder theorem there. So when we use the same numbers again, 65 into 78 divided by 9. So 9 into 60 divided by 65 is effectively 2, I just told you. And this is effectively 6. So 6 into 2 is 12. But no remainder can be more than 9 here. So effectively your answer is 12 minus 9 is 3. So whatever the remainder is, if it is more than what your divisor was, then 12 minus that divisor, or basically whatever the result minus the divisor, is equal to the final answer, and that's the solution. There is another way of solving the same question. This is 2, this is minus 3, which is basically the difference between 81 and 78, which is effectively minus 6. 2 into minus 3. Now I told you, you can just subtract this 2, which is 9 minus 6 is equal to 3, which is the solution we got previously also. So you can see, using both the methodology, we can actually get back to the same answer, and you can choose either of them. But before we move to the next thing, I want to make one thing very clear, is that how do you choose basically whether to go with a positive number or a negative one. The simple trick that works for me is that try to choose with the number where the magnitude is less, because addition, subtraction, or any other mathematical function on a lesser magnitude number is way easier than something when you do it on a bigger magnitude number, and that's a concept I would suggest you to go ahead with while solving any paper. So now we move on to the concept of remainder theorem in factorials. So I'll give you one question and we'll try to solve that using remainder theorem. 1 factorial plus 2 factorial, like this we add up to 2019 factorial whole divided by 10. So it is 1 factorial plus 2 factorial, like this, added up to 2019 factorial. If you remember, 5 factorial is 1 into 2 into 3 into 4 into 5, which is effectively 120. Okay. So you have a 0 here, which is a basically tells this is a multiple of 10. And what the question stated is the whole divided by 10. So we know post 5 factorial, everything will be a multiple of 10. And the 6 factorial is basically 720. 5 factorial into 6. Okay. So the question then, you can reduce the question to basically the question will be 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial whole divided by 10 plus x, which is the other summation, divided by 10. If you remember, the x is 5 factorial till 2019 factorial. This whole every other the factorial is a multiple of 10. Hence what we can do is the remainder of this particular equation is 0. Now we are left with only this part. Okay, so 1 factorial plus 2 factorial, what we can do is basically 1 plus 2 plus 6 plus 24. If you see, 6 and 24 are again, the addition is 30, which is effectively again a multiple of 10. So we can eliminate those two also. 1 plus 2 by 10 is equal to 3, and hence 3 is the remainder. So you see how a complex question gets simplified to just this, and that's the beauty of a remainder theorem. Say you will get questions in competitions like, say, 2 to the power 63 by 9. So what you have to, basically the trick is that you have to find a multiple of 2 which is having the minimum remainder with the divisor, that is 9. If you see 2 cube, which is essentially 2 cube is 8. 8 is having a remainder of minus 1 with 9. Correct? Now, so I can rewrite this problem like 2 cube whole to the power 21 by 9. 2 cube is 8. So 8 and 9, I just told you the remainder is minus 1 whole to the power 21. So the remainder is minus 1. Minus 1 to the odd power is basically minus 1. So 9 minus 1, the remainder is 8. And this is the solution. These are the questions you will get often in competitive exam, and this is the way you can actually go ahead and solve those questions. So next there is Fermi's theorem. Okay, so I will tell you. So P is a prime number and A is just any other number. So this is something I want you to remember while we are basically finding this theorem. So what this theorem tells is basically A to the power prime minus 1 whole divided by that prime number is 1. So let's see an example and you can get it. 2 divided by 72 whole by 73 is equal to 1. So the number goes like this. 73 is a prime number, which is the P. 72 is basically 73 minus 1, which is P minus 1, and 2 is A. So A to the power P minus 1 whole divided by P, and hence the remainder is 1, which the Fermi theorem specifies. I'll actually solve one question for you. 2 to the power 106 whole divided by 53. So this is the question. Can I write this as 2 to the power 52 5 into 2 to the power 52 into 2 to the power 4, sorry, 2 to the power 2 by 53. Okay, 53 is a prime number. You can see this is p minus 1, this is p, so it is in the form of a Fermi theorem, is a to the power p minus 1 by p. So this one are both in that form. So I can write it as 1 into 1. 2 square is effectively 4. So the equation basically is this now. You can write this as 1 into 1 into 4 whole divided by 53. So the answer is 4. And this is how you go about using Fermi theorem to solve any question. We'll move on to the Wilson theorem. What it states is that p minus 1 factorial by p stands for prime, is equal to p minus 1. So this is the question. So the question can be like 2 factorial by 3, which is basically p minus 1 or 3 minus 1 is 2. Got it? Similarly, you can use any question like say solve for 4 factorial whole divided by 5. The answer will be 4, as in 24 divided by 5 is a 4. So this is the equation you can use while solving factorial questions with remainder theorem. So now we'll move on to the cyclicity pattern, and we'll solve a couple of type of questions in this, and I think we'll be good to close the session for today. Post that. So you will often get questions like 37 divided by 7 whole to the power of 100. So this is the question, you have to find the remainder. Okay, so the question can be formalized as 37 is having a remainder of 2 with 7, which is effectively 2 to the power 100 by 7. Then 7 into 5 is 35, if you remember. And hence 2. Now, what multiple of 2 is having the lowest remainder with 7? If you remember from the previous examples we solved, 2 cube is 8, which is having a remainder of 1 with 7. So I can break this into 2 cube whole to the power 33 into 2 by 7. So 2 cube to the power 33 is effectively 2 to the power 99 into 2 is 2 to the power 100 divided by 7. So 2 cube will have a remainder of 1 with 7, which is 8 divided by 7 is 1. 1 to the power 33 is 1 into 2 is 2. So effectively the question simplifies to 1 to the power 33 into 2 by 7. So effectively the answer is 2. So this is the cyclicity question that you often get. The trick is you have to find the number from which is having the lowest magnitude remainder with the divisor. That's it. Thank you for watching the video. Hope you liked the solution. Please don't forget to subscribe and like my video. Thanks once again.